This episode, I will conclude on the previous 9 episodes. So, I have introduced you about role of statistics in research, that it aims to quantify things. One of the main things is the errors for judgment, the magnitude of effect here, and the error for judgment. So the first thing I like to conclude is that statistics quantify the magnitude of effect for making a conclusion, which is here. I paste the study that I have used as an example in the early slides. So we focus here when we read a paper. It is the body of the knowledge. It will be generalized to the other groups. Knowledge is universal. So this is the first things that we aim for when we read a paper. Also, when we doing a research and writing a manuscript for publications, we also focus in here what we add to the society. So this is very important. Now the next one is, what is the basis that this claim use? So this one, we work backward. This one is the magnitude of effect. So in this example, it is about the vaccine efficacy. So this one, it quantify the magnitude of effect for making the conclusions here. You need to know where is, when you read the paper, where is the main finding and where is the main conclusions, and see if you believe it. So that's for judgment. Now, there are two components that should be reported in the research paper. The first one, we quantified what was found in our study sample. So here it's about vaccine efficacy. So it tells us about 1/3 of the people who received the vaccines was prevented. The second component is the parameters, which is what would be found in the population where this vaccine will be used. So it will be in future, right? So these two components should be reported. Without this, we cannot judge about the claim or the conclusions that we can rely on, we can believe it or not. All right. Now, in statistical inference, there are two types. The first one is parameter estimation. So it's use the information from the sample to inference to the larger populations. If we do 100 times of the study similar to this, the vaccine efficacy could range from 1 to 52%. Okay, we're 95% sure about that. So this is the parameter estimation. The second component, the second type is the hypothesis testing. It's quantify the chance of getting the effect of this or more extreme under the null hypothesis of no efficacy. So the answer here is significant, p-value of less than 0.04. So this is two types of statistical inference. The main focus in statistical inference is that the first one, you read the conclusion and see here the magnitude of effect, that this effect is meaningfully large or not. Large so that you can, or it's reasonably to conclude like this. So I remark here, we need to focus at the magnitude, how large is the effect, not the width, that is wide or it's narrow, and not that the interval include or overlap or cover the null value of no efficacy. No, just about how large is it. For example here, is it 1% beneficial to receive the vaccine? So many people will say no. That means we look at how large is it effect. How about the upper limit? Will you happy to receive a vaccine that can prevent the disease about 52%? Okay, so these are all judgment. The one who read the paper should have something. The researcher also have something, that is they put it here, may reduce risk. All right. The second one, the main focus, I would say that the p-value of less than 0.05 is the common cut point to say statistically significance, in short. But in the longer sentence, I have already talked about that in the previous slides. I put it here, avoid to over-rely on it, because in fact, it cannot relate that to about the effect at all. So it can be omitted. I mean, you can skip it, not report in the paper. Why? Okay, let's take a look. If we have a paper like this, and it is the main things that you have, and you will make decisions about to get this treatment or not. But that paper did not present the red one here, did not present about the magnitude of effect, but just p-value. It would say something like, this vaccine is significantly prevented the HIV infection, right? Because p-value is less than 0.05. So it's totally misleading about this, that this vaccine is work. But in fact, we don't know that it's work or not work, according to the confidence interval here. That is why the paper that present only the p-value tend to be misleading, and the reader cannot have any evidence to judge against that to be safe. So this is the main focus. What I have already talked in the previous slide, previous previous episodes. Then, after that, after we know about everything here, how this is calculated, and what is the theory behind that in the previous episodes, then what next? The first one is about the precision issues. When we talk about the precisions regarding the answer for that research question, we talk about conclusive or inconclusive finding. So to be conclusive, the confidence interval need not cover the meaningful value. Usually it's not the null value, it's some. Null here means zero, means no efficacy. But some, for example, if the vaccine can be beneficial, it should prevent about, for example, in general, 80%, for example. But for some very dangerous disease like this, we might tolerate up to even 10, for example. That's my opinion. So that is not zero, it's 10% prevented at minimum. So the maximum or the upper limit, I don't care, because if the minimum at least 10%, I will happy to receive it. That means we have the meaningful value of 10%, for example. So there are many criteria about this, or what should be about meaningful level. So that's the first one. If 10% being included in the interval, that means inconclusive, for example. The magnitude of the lower or the upper limit of the CI is large enough. Why? Lower or upper? It depends on the magnitude of effect. So if it is 10, so I consider the lower limit. But if it is 80%, I consider the upper limit. If at best it's only 52, it should be 80%. That means this already conclusive that there is no benefits, for example. Okay. Look at the magnitude. So the last one, in planning phase, not after the results is finished. In planning phase means we plan for the study or we design it. This issue is about sample size calculation. We can discuss about the sample size calculations in the future lecture. So precision issue is then issues after we is the only issues after the study is finished, not the sample size. The sample size will always insufficient if it's inconclusive. Okay, but we can plan. Design the study before conduct it. Consider about at the end how large is the sample size we need to get a precise estimate, or how large are the sample size to get the significant findings. There are two approaches, but this one, as you can see, is more important. We will discuss in details when we meet in the class. The second issue is about validity of the study. So after you agree with the conclusions and based on this evidence, the next issue would be, can this be wrong? It could be wrong by the biases, which I taught in the previous episodes about selection bias. Is an issue for this or not? Information bias, or how about the confounding bias, or many others. So that's the next issue. The next issues. Or it could be wrong by the wrong data. The research is not conducted in the way that the quality assurance is implemented reasonably, or data management is inappropriate, for example. So this is another one. And the last one is, or if it's wrong because of the methods of analysis. So all three issues here, we really need to look for in the details of the full paper. And if we plan to do some study, we really need to touch this one by prevent it, have a mechanism to prevent it, to minimize it. Or if not possible, you discuss it in the discussion section, for example. So this usually cover in the class about critical appraisal or evidence-based clinical practice, evidence-based medicine. We shall have some class about that in future. Before I move, I like to make a remark that, as you can see now, statistics is really not only calculation, not only mathematics, but it's really related on the logic, as I have shown you, and judgment. So these two components is rarely taught in the school. You really need to touch it by practicing. And it's more difficult. We can talk about that in details when we meet. And about mathematics, which is the most easy part, there is a guide to let us know about what method of analysis should be used to prevent the last cause of error. So I have mentioned about four most common types of the study outcome or dependent variables that determine statistics. So that means that's a guide. Please don't worry if you don't understand about anything here. I just want to tell you that there is a guide. Even you don't know what are these, but you should know about your study, what is the dependent variable or the primary outcome, and what types of it. Then there are many books, many resources, or even consult the statisticians near you. It's easy about after this. Don't worry. But of course, we need to touch it in real practice when we meet. And another issue I like also to remark that all ordinary statistics assume the observations being independent, but if there is dependency among observations of the outcome, we need to use a special method, not an ordinary one. Again, don't worry about these names. We will touch it. It's easy. About mathematics, don't worry. And my final remark is that whatever you use, don't forget the basis of it. Every research, especially clinical research, we need to quantify the magnitude of effect with incorporating the error for judgment. So whatever statistics we use just to ensure it's appropriate, here are just most common methods that I mentioned. So the magnitude could be with or without comparison. A single measurements like prevalence, incidence, mean, or whatever, or the mean difference, the ratio difference, the rate difference, or whatever, or ratio. Whatever it is, we use after we apply statistical method. Need to quantify this. All quantifications about all this I have put in the previous episodes about central limit theorem and how we can calculate for the CI and p-value. In that episode, I use the continuous outcome, but it can apply to any, the same principle. So I hope you have a strong understanding about the principle of statistical inference to understand about how this be calculated and its interpretation. As long as we answer the research question based on the magnitude of the effect, which is lower or upper limit depending on the study objective, it will always be safe. Even you have your own opinion, your audience still have the evidence for their own judgment, that we make a good thing to the society, we add something, we don't mislead them,